Today we're going to start looking at section 6.1. Our objective is to use the fundamental trig identities to verify identities. Now remember, we've talked a lot about these identities in the past, so we're going to continue to expand on these identities. We've got our reciprocal identities, quotient identities, Pythagorean identities, and the even-odd identities. So let's talk about what verifying represents. So remember, in order to verify, what we're going to do is we are going to look at how the fundamental trig identities are used to establish other relationships among these trig functions. To verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. Each side of the equation is manipulated independently of the other. We start with the side containing the more complicated expression. When we substitute one or more of our identities on that complicated side, well, we're going to be able to then rewrite it, where then eventually it's going to turn identical to the other side that we have not touched. Okay, so once again, I cannot stress enough, we're starting with one side, only changing that side, and eventually it will turn into the side that we have not touched. We've got several strategies to help us out. So let's look at this first strategy. We're going to be able to rewrite the more complicated side so that it only contains sines and cosines. So let's take a look at this example where it's asking for us to verify that the cosecant of x times the tangent of x equals the secant of x. So now if we had to pick which one of these sides looks more complicated, I would probably pick the side that contains the two expressions rather than the one. So I'm going to start with the left side where the cosecant of x is being multiplied by the tangent of x. So I'm going to write this side, and now I'm going to start manipulating it so then eventually it is going to be turned into the secant of x. So what's going to help us out with this? Well, the strategy said let's turn things into sine and cosine. If I have cosecants, well, using our reciprocal identity, I know that cosecant relates to sine. If I want to get rid of tangents, it deals with both sine and cosine. So notice that these were the two identities that are going to help us out. Cosecant is 1 over sine, and tangent is sine over cosine. So essentially, I'm going to replace what cosecant and tangent are with these two terms. So cosecant is now really 1 over the sine of x, and that's now being multiplied by tangent, which is going to be replaced as the sine of x over the cosine of x. Now I have two fractions being multiplied together, but everything's in terms of sine and cosine. We multiply fractions straight across, so we'll have the sine of x on the top and the sine of x times the cosine of x on the bottom. Okay, this takes us back to reviewing how do you simplify rational expressions. Because I cannot factor the numerator and the denominator, I'm going to be able to reduce down the sine, because that's something that's both in the top and the bottom, and that then gives me 1 over the cosine of x. I'm still not done though, because remember, I want it to turn into the right side. The right side is the secant of x. However, with 1 over cosine, if we go back to our identities, our reciprocal identity tells us that 1 over cosine is the same thing as secant. So notice that 1 over cosine is the same thing as secant of x, and notice that it took us 4 steps, but we were able to manipulate and verify that the cosecant of x times the tangent of x is really the secant of x. And that's verifying. Let's look at this example. I want to verify that the cotangent of negative x times the sine of x equals negative cosine of x. Once again, we have to pick the more complicated side. Hopefully we notice that the left side is a little bit more intense than the right. So I'm going to start by rewriting the left side. And I'm going to, once again, think about our strategy of let's turn things into sine and cosine. I'm actually going to put a pin in that for a second, because notice that I see a negative angle. And so honestly, I want to take care of that negative angle first. If we look down at the even and odd identities, Remember, when you have a negative angle in terms of cotangent, it's the same thing as negative cotangent of x. So that's actually the first thing I'm going to do to get rid of that negative angle. And then I'll proceed with my thought process of turning things into sine and cosine. Because that second term is already sine, I don't have to do anything there. However, cotangent is something that I can manipulate. Cotangent, if we think about the identities that we have involving cotangent, the quotient identity tells us the cotangent is cosine over sine. So I'm going to replace cotangent with that fraction. Now, because cotangent is negative, I'm going to keep the negative sign, and I'm going to have cosine of x over the sine of x. So really, that negative can go with either one of those terms. I'm going to keep it on the top with the numerator, and then that's still being multiplied by the sine of x. Now, because these two things are being multiplied together, I could technically make that sign a fraction by putting it over 1. Just like our last example, we multiply fractions straight across. So negative cosine of x times the sine of x is on the top. 1 times the sine of x is just the sine of x on the bottom. There's nothing that I can do to factor because everything is essentially a monomial. So now I can reduce because there is a sine of x in both the top and the bottom. Notice that by reducing that down, it gives me a negative cosine of x, and that's exactly what the right side was asking me to turn it into. So we're done. A second strategy is us factoring in order to start simplifying these trig expressions. So factor. So if we take a look at this example, it says it wants us to verify that the sine of x minus the sine of x times the cosine squared of x equals the sine cubed of x. Notice that I'm not going to use that strategy of turning things into sine and cosine because they already are. So that's why we had to come up with this second strategy. Once again, we want to look at what side is more complicated because that's the side we're going to start with. And hopefully we're all okay with the fact that the left side is definitely more complicated than the right. So I'm going to start with the left side. And like our second strategy tells us, well, let's look to see if we can factor. Anytime you have addition or subtraction signs breaking up terms, when you factor, remember, think about GCFs. What do those two terms have in common if they do? Both of these happen to have a sine of x. So I'm going to factor out a sine of x. Notice that that would leave me then with a 1 minus the cosine squared of x. So that's us factoring it out. Well, now what can we do? Because my end goal is to turn it into sine cubed of x, I don't want to change sine of x. That means I want to look at how do I change 1 minus cosine squared of x so it can turn from a cosine into a sine. Well, if we look back at our trig identities, we are dealing with the Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. Because this in parentheses says 1 minus cosine squared, well, that's because we decided to subtract cosine squared of x over to the other side of the equation. And notice that by doing that, it's going to leave us then with sine squared of x. So I get to replace what I have in parentheses. 1 minus cosine squared of x is really sine squared of x. Now everything's in terms of sine. When you multiply, I get to add the exponents. Well, technically there's a positive 1 exponent here. When I add those exponents, I have to keep the base. So that's why the sine stays as it is. 1 plus 2 is 3. That's why sine cubed of x is my answer. I am done. Our third and final strategy that we're going to talk about today is using substitution in general. I know we've talked about replacing things in terms of sine and cosine, but it's not always going to be sine and cosine that we can replace. So if we're looking at all of our trig identities, we can try to use substitution to replace one of our trig expressions with an equivalent trig expression. So here is my example. Let's verify that the cosine squared of x minus the sine squared of x equals 2 times cosine squared of x minus 1. Both sides look somewhat complicated. So what I'm going to focus on is the fact that on the left, there's not just one trig function. There are two different ones. There's a cosine squared and there's a sine squared. So to me, that might be a little bit more of the intricate or more complicated one. So I'm going to start with the left side and I'm going to manipulate it and turn it in to the right side. So how am I going to do that? Well, because the right side is only dealing with cosine squared, I'm going to leave the cosine squared as it is, but notice that that means that the sine squared term is going to have to get manipulated. If we look at our identities, anytime we're talking about squared terms, we're talking about the Pythagorean identities. So if I want to know how can I replace sine squared, just like in our last problem, I'm going to manipulate this Pythagorean identity to get sine squared by itself. I once again want to subtract cosine squared of x over to the other side. So I'm going to leave the cosine squared of x term minus, but now in parentheses, I'm replacing sine squared with 1 minus cosine squared of x, because we were able to use that Pythagorean identity and essentially replace it with its equivalent piece. I'm going to distribute the negative to get rid of the parentheses. We'll have our cosine squared of x. Now we have minus 1 plus cosine squared of x. We have several like terms. Cosine squared plus cosine squared gives us 2 cosine squared. So notice that by replacing sine squared with 1 minus cosine squared, we were able to manipulate the left side to turn into the right side of 2 times the cosine squared of x minus 1. So that is what I wanted us to focus on today. We have 3 strategies to help us verify identities. I would like you to work on page 596, doing problems 1 through 9 and skipping problem number 4.